Welcome back, everybody. Today we're going to try the second pawn challenge on pwnable.kr. Last time we solved the first one, and today we're going to check out this collision challenge. These challenges are intentionally set up servers on which you have to capture a flag by exploiting some software or by finding the hack to get the flag. And it is not known at the beginning what the flag is. We will see what it is for this challenge right now. So, opening the second challenge, we see the text, "Daddy told me about cool MD5 hash collision today. I want to do something like that too." MD5 collision is already something I can say a bit about. MD5 is a hash algorithm, so that's already good that we have some base knowledge here. It is a hash algorithm in which you can input any data and it will produce a string like this. And if you input another string, even if it's just slightly altered, the output will be completely different. So see, this is a very different output, and this is a different output, and this one produces a different output as well. However, since the length of this output string of the MD5 hash is limited, and the length of the input is not limited, I mean, we can input these things here, inevitably the MD5 some algorithm will produce collisions, which means that for two different input strings, we will get the same outputs, the same output hash. And that is something we are going to deal with today, I suppose. At least that's what a MD5 hash collision is. So let's log into this server via SSH and see what awaits us there. Password is guest. Yes, I want to add the fingerprint guest. And this right here is the server pwnable.kr. And let's see what we can find here. I first start out by listing the files, and we see a binary file call, then which probably stands for collision, then call.c and flag. So this is very similar to last time, and let's just execute the call command, the call binary naively to just see what it does. Usage, call, passcode. So apparently we have to provide a passcode, and if I call it with some string passcode, it says passcode length should be 20 bytes. How many bytes is one character? One character is 8 bits, so 20 characters, I guess. Or depends on the character set that is used. Let's just try 20 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 20 characters. Okay, that is 20 bytes. So 20 bytes in this case is 20 characters. But what if I input a special character such as this? Okay, then it does not work again because that is not part of the character set. Yeah, and if for the special character, I have to remove 2 characters from the entire string. Then I'd say it would be a good idea to look at the source code of this and find out what is being done here. We have a main function that checks the number of arguments here. This is the one we already saw. Then the one that checks the string length. So this takes in the argument 1, so that is the argument we provide. And string length will apparently return the number of bytes in the string. Then if the hash code equals hash code, where does that come from right now? Okay, there's a hash code. Let us say constant in this case. Well, it's not technically a constant, but it's a defined code right here. If this hash code equals check password, which is this method called on the argument 1, then it will open up the flag for us. It will do a system call bin cut flag. That's something I'm wondering about. So the problem here is that we have a flag file here, but we can't open it. We can't see what is in there. It says permission denied. Then why is it possible for the call binary to access that flag? I mean, because the C source code here says the flag can be printed, or the cut command can be used with the flag, which we can't do right now. Let me just show you that. So the command called is bin cut /bin/cut. Can't write vim info file. Yeah. So that's the command the binary is calling, but we can't call it. Why is that the case? I don't know. Permissions denied. So how does this executable have the permissions if we as the user without permissions execute the executable? That is something I'm wondering about. So the call C source code was is owned by root, and everybody has read permissions on it. What is the S flag? That is something I'm wondering about right now. Linux file permissions. Let's have a look. I read about that S flag before, but I've always keep forgetting it. How do you read file permissions? Yeah. What are special file permissions? Linux file permissions S. This is typically used with files owned by root to allow normal users to execute them as root with no external tools. Aha. Okay. That is probably the answer to my question. So the leftmost file permissions, the leftmost dash says it is a file, because if it was not, it would print AD. Then the first 3 characters, are they group or are they user permissions? I keep forgetting that. I really have to deal with file permissions way too rarely. There's an image here. Okay, the leftmost 3 characters depict the permissions for the file owner. The middle file permissions are for the group owner, and the rightmost are for all other users. The S is the setuid bit, which tells the OS to execute the program with the user ID of its owner. This is typically used with files owned by root to allow normal users to execute them as root with no external tools. Okay, alright, I'm fine with that answer. So, can I use tmux here? Yes, I can. So I would say vim this file here and keep a terminal open on the right side, like this. Okay, so again, looking at the code, what does check password do? Check password takes a constant character pointer p, so that is just a pointer with a fixed memory location that is constant, and p is the reference to an integer. No, is it? P is, what is the deref? I'm way too bad at C. CD reference pointer. I really don't like these search results on Google recently. I would be way happier if they just list the official sources or authoritative sources as the top results, for example, gnu.org. The main use of a pointer value is to dereference it with the unary asterisk operator. For instance, asterisk and I is the value at i's address. Let's have a look at this example code here. There's an integer I, then there's a pointer. The pointer is assigned the address of I, and I is 5. If we dereference the pointer, then this will return 5. But is that a dereference here? And no, probably not. It's not. This is just a type assignment. The character pointer is cast to an integer pointer, I think. And this is the internal pointer or integer pointer, whatever. Then I int result is 0 for, and it is the software loops over, what does it loop over? Each integer in the character pointer and adds it to the result. Okay, one thing that is interesting here is that we pass in a character pointer, so that is the string we input, and it is converted to an integer pointer. And the character pointer is supposed to be 20 bytes long, while the integer pointer is looped only over 5 indexes or indices. And this has probably something to do with the fact that integers are longer than characters. I think integers it depends on the machine, but here they are probably 4 bytes long. One integer is 4 bytes. And one character is just 1 byte. And that's why here we only have to count up to 5 instead of counting up to 20. So that is my assumption for now. And we take what is being done here exactly? The integer pointer at position I is added onto the result. This hash code here has a length of 1 digit in hexadecimal has 2 digits in hexadecimal make up 1 byte. So this is 1 byte, 2 bytes, 3 bytes, 4 bytes. No, 1, 2, 3, 4 bytes. So this is only 4 bytes. Okay, this is probably very simple reverse engineering. We just have to find the string to input, which when we produce a hash sum, a very simple sum of it, which produces this hash code. I actually don't understand what this has to do with MD5 in and of itself, because the Pawn Challenge says, Daddy told me about cool MD5 hash collisions today. I want to do something like that too. Okay, so we have to find some input that collides, that produces a hash code that matches this one. So we have to produce a hash collision, and there are many hash collisions possible, many inputs that will produce this hash code probably. But what is it exactly? What input? How can we decipher it? I'm not really sure about the entire result having to be equal to this hash code. This is just a cross sum. I mean, we're taking the individual numbers, the individual integers in this pointer, and adding them up to produce this. And this should be, well, what input produces, any sum that produces this result will work as an input, if my understanding is correct. So we can just pull up an hexadecimal converter to just see what that number is, just to improve our understanding of the situation a bit. Copy pasting in Linux is always fun. Okay, so that is the number. How do we produce an input that matches this number? I would say okay, we put in characters, a character pointer, basically a string. Then it is cast to an integer pointer. And of that integer pointer, a cross sum is taken over the first 5 entries. Is there something like paint here? Yes. So I'm just thinking we put in some input strings such as cool dude, like this. Then the check password takes this entire pointer and casts it to an integer pointer. So this pointer will be divided into integer. This is the first entry, number 0. This is the second, number 1, etc. So the string must be longer. And all of this makes up the integer pointer. So just to be clear, this is how it works, or this is how my understanding is that it works. So the first integer entry is made up by the first 4 numbers or 4 characters, and they are converted to, well, of course, to bit level, and then that is converted to an integer. Is there a clever way to do that? Of course, we could now calculate the input of this, but is there a better way? And the expected result is this number. We input 5 integers, so let's divide that number by 5. Does this machine have Python? Probably not. Python 3. Oh, it does. Oh, nice. Okay. I would like to divide that number by 5. So that is a floating point number. I would like to get an even result. How about 4? It's divisible by 4. We can make it simpler. I was thinking about we can provide 4 integers and just make the next one 0. But we can probably also provide 2 integers and make the remaining 3 0. And by that same thought, we can provide 1 integer, that is this one, and make all the remaining ones 0. So we have to find one character combination which would be converted to this integer, and we can just leave the rest empty. That is my line of thought right now. What is that number in binary? Convert to binary. This is binary. This would be the first. Oh, is there a chance that a character is just 4 bits? No, it should be 8. So let's find the character binary to character. Would be much nicer if I did that using Python somehow. Let's do it using Python. We can learn something along the way. I'm sick of using these online converters over and over. Python integer to binary. You can use the bin function here, obviously. In Python, everything is easy. Let's call this hash code decimal. Hash code decimal is okay. Then hash code binary is binary of hash code decimal, print hash code binary, and that is this number here. Great. Then I would like to delimit this. I would like to separate this out into different characters. Python split binary string. You can use slicing on byte objects. What happens if I do this? If I just access the 0th index. Okay, this will print the individual characters there. That's not what we want. Okay, let's just make it plain simple. Hashcode binary starting from character 2. This should be the first after the B. And then what type is this? Python get type of variable. Use type, yeah, of course. I already guessed correctly. Hashcode binary is a string. Yeah, okay, it's a string. Then I would like to take from that string characters 2, and then add 8 on top of that would be 10. So that is the first character in that string, if I understand it correctly. Let me call it C1. Then let's find C2 and here we would have to ask for, I think, 10 to 18. Yeah. C3 would be 18 to 26. Print C3. So that should be these ones. No. This is 1, 2. Whatever. 0, 0, 1, 0, 0, 1, 1, 1. It looks like this part right here. So 2 to 10 is this. Then 10 to 18 is this. 18 to 26 is this. Why are there only 6 bytes remaining? Probably because there are leading to zeros which are missing in our printout. So I would like to get a better printout. Python binary function prepend. We can of course also prepend manually. Hashcode bin is this, and we're going to prepend to zeros, and that should result in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 4, 5, 6, 7, 8, 9, 10, 1, 2. So that is 32 bits, which is equal to 4 bytes. That is okay. I will accept that. Just to be sure, we can also make this binary string an integer. Python binary to integer, and see, just confirm that the same number is returned, the same hash. No. Of course, it will just take this as a literal integer, but it does not recognize that it's binary. Because of that, we have to provide that it's a base 2 thing. Base 2. Oh. And that is this number, and this looks like the number we had here. Okay, so the conversion is correct. Yeah. And then I would like to take from the hash code, character 1 is, can we just do this? Hash code bin. And I want to take bits 0 to 8. Will this work? Character of this. This will be the hashcode bin at 0 to 8 will return a string. Probably we have to make this an integer at base 2. C1 is an exclamation mark. Okay. Let's just try to keep up that same method and do the same for the next character. C2 is this thing right there. C3 will be 16 to 24. \t, okay, tab character. C4 will be 24 to 32. C4. So these are the characters. What is, okay, let's just produce C0, which is going to be the filler character, which should produce or have the value 0. Okay. And now I think we are ready to try. Exclamation mark. This thing. Probably this will not be recognized as special characters, or this will be, I don't know. Let's try if it works. No, okay, this is evaluated by bash. So this is not good. How can we get this binary information into this executable as an input? As an input argument, we could of course somehow pipe it in and then use xargs. No, I did not call the script. I did not call the binary. I called .call c. So we have to call this thing. Event not found. Call. And then this has to be recognized as one input argument, but how? So just to summarize, just to make it clear, I'm just thinking of ways to provide this binary input to the executable. Oh, sorry. No, this is probably wrong anyways, because the C function here adds the individual characters. No, that's fine. I think it's fine. Our 5 characters here, they are, well, probably I'm supplying them in the wrong order, but if we do this, and then this, what would be the correct order? It should be the 0 bits first, and then the exclamation mark is the first one, and this Y, the tab character, and this should be the correct order. And then if it complains about bytes missing, then we should prepend more zeros. But this of course does not work. How can we provide bash binary can bash run binary with arguments? No, bash special characters in arguments. You can either escape each single special symbol with a backslash. Yes. Or double quote the entire argument. I'm even wondering about this 0 argument. Does it... Backslash x00. Okay, apparently it is recognized as a character. Let's see how many I need to provide. 5. Okay, so this is recognized as one 4 bytes character. Okay, so this is kind of a good sign, and then we have to replace this with an exclamation mark and see if it still works. Yes, the exclamation mark is taken as input as well. Then backslash t, let's see if that works. Yes. No, it's not taken in. What am I doing? So this is taken in as input because it prints wrong passcode. So at least it has the correct byte length. If we replace the first character or the second character with a backslash exclamation mark, it complains that the passcode length is not 20 bytes. Let's try the following. Backslash 0 should still be the 0 character. It's not. When you give the string literal backslash 0, you effectively denote a string with exactly one character, which is the unprintable null character. You can represent this as backslash 0 in string literals. Now I still think this is our basis to work with, and we have to somehow get the exclamation mark in. This prints wrong password. Backslash exclamation mark. Why does the exclamation mark not work? Here it says the byte length is wrong. Why? Because the exclamation mark is... Why? This right here is the exclamation mark. At least that's my understanding. Let's just confirm this online. Binary to character. No. It's an exclamation mark. I am not really happy with trying to figure out the characters which bash accepts to pass as an input argument. Passing binary data as arguments in bash. Does that work? Bash is not good at dealing with binary data. Yes, I found that out already. I would recommend using base64 to encode it and then decode it inside of the script. Yes, but that's not really what I need, I think. Save your binary data to a file, then do script. Cut file. There's no way to pass a null byte in the parameter of a command. This is not because of a limitation of bash, although bash has this limitation as well. This is a limitation of the interface to run a command. It treats a null byte as the end of a parameter. There's no escaping mechanism. Okay, but here it apparently accepted multiple null bytes. Let's see again. Yeah. Bash is not best suited to handle binary data directly. Either use... yeah, let's not focus on bash because that's just the shell. Let's focus on how to pass binary data as argument in Linux. This should probably be some standard I/O thing. There isn't a good way to pass null bytes to a program's arguments. Well, there must be a way. Maybe we're going in the wrong direction. So, the expected hash code is this, check password is this. It should be fairly easy to find something that when added up results in this hash code. We pass the input string here. The input string is converted to an integer pointer. Integer pointer would resemble the characters bundled up together and crunched into an integer. at least a part of the characters. Let's say 2 characters together are an integer, or 4 characters together are an integer. Then this is just so easy. To me, it's not, the problem is not understanding what the binary does. It's just understanding how to find an input, or how to pass the correct input into that binary. That is what I'm struggling to do right now, but probably I'm still thinking the wrong direction. Okay, let's start from almost scratch. Which variables do I have available here? We have the hashcode decimal. That is the hashcode decimal. Hashcode decimal divided by 4 would be this. How much can we divide it? Maybe by 8? No. 16? Not really. Let's print the binary representation of hashcode decimal divided by 4. We have 20 bytes. An integer's most likely 4 bytes. I think. Or is it 2 bytes? Anyhow, the integer... no, hashcode decimal... Maybe it's possible to paste hexadecimal as it? No, probably not. We're taking the arguments, we're converting the argument characters into integers, then we're adding them up. And the result should be the hash code. This is binary right here. We could... No, this is supposed to be the entire sum of the integers provided through the character pointer. So it's very confusing as to how to get such a large number, in my opinion. The password is checked here and it's compared with the hash code. The hash code is an unsigned long. This is 1 byte, 2 bytes, 3 bytes, 4 bytes. So this is 32 bits. That means an integer is 2 bytes probably. This means that two characters, which are each 1 byte, are jumbled up together and converted to one integer. So the question is here, I mean, this is a 32-bit number. I think this is one. This is a 32-bit number. How do we get such a large number by just adding 5 16-bit numbers up? It does not make any sense. Or does it? the result is an integer here, and the method returns result, but it returns it as an unsigned long. This is a signed integer. Signed integer, unsigned long. Signed integers are much smaller than unsigned longs. So how is this supposed to ever equal the hash code? Yeah, it does not make any sense. This is completely out of range. This integer time for a new drawing. This integer is about that long. That's 2 bytes. Byte 1, byte 2. And this, and here the first bit is taken as a positive or negative sign. So this is the information. But the hash code is twice as large, and it does not even have the sign information. So this has much more. I'm not sure how this is. Is this... Wait, this is the pointer. Is the result... Wait, no, this is the pointer. By accessing the index, it should also be dereferenced. So this should be the value, actually. Let's look for some mental help. Can't solve, crack me. Result is added. we pass in 20 bytes. 20 bytes. I pass here. Then the 20 bytes. So this is a 20 bytes string. It is filled with information, ones and zeros. By converting it to an integer pointer, what changes? Instead of a character pointer would manage the indices at character level, so that would mean that 8 bits together are one character, and that means also that the indices would resemble this structure. An integer pointer would change this so that that 16 bits together form one integer, so the index 0 would resemble the first 16 bits instead of the first 8 bits. That is the integer we're passing. Oh, that is the expected hash code. And by dividing it by 5, that is not as... Well, maybe it would work. Dividing it by 4 would not work since we have to pass a null character. Or maybe it would work, but I don't know for sure. If we... what's the result of this? How is this a... Why is this not equal to... No, why is this not equal to this? Oh, it is. Why was it not beforehand? Again, 21DD09EC. That is the integer. If we take just the integer and divide it by 5... Huh? Did I do a mistake earlier? I thought this was a floating point number with a 0.5 at the end. Okay, let's try to work with this. So each character has to resemble this integer number, because by adding this up 5 times, this is what we get. Just to be sure, let's do 8 times 5. And this is not the result. But anyways, we can just add 4 at the end of the input, probably. No, wait, let's do it again. That is the integer value. If we divide this integer value by 5 and then multiply it by 5 again, we are missing 4, a count of 4. But okay, let's just assume this is fine for now. And let's say we take this integer and we would like to represent this integer through 2 characters. To do that, we can convert it to binary. That is the binary representation. And 2 characters should be... Wait, that's not possible. This is just too long to represent this, to represent 2 characters. This is 1 character. This is another. Let's say this is another. Yeah. The input passcode should be 20 bytes. How should 20 bytes ever result in a hash code that is well, it's 4 bytes. This is 4 bytes. The input passcode should be 20 bytes. What makes this so difficult? I don't get it. We input 20 bytes. From 20 bytes, we should be able to derive a passcode that is... this is 1 byte, this is 1 byte, this is 1 byte, and this is 1 byte. So what is so difficult about this? I don't get it. This is making me... I'm getting a bit peeved from that. Let's again check what is the... Let's try to think on byte level. The input passcode length should be 20 bytes. This here... Oh. The number... Okay, we paste in 20 bytes. And we sum those 20 bytes up. No. We divide those in 5 packets of 4 bytes each, and then we sum those up to result in a 4-byte hash code. This is not difficult. I just know this is not difficult. This hexadecimal number divided by 4 is this. No, we should not divide the hexadecimal number by 4. Maybe we should. We should. Okay, binary of this hexadecimal number is this. This is our 4 bytes hexadecimal. Then we could say the input characters, each character, no, we input 20 bytes, which is a much longer string than this byte string. It should resemble one, two, three, 4, 5, 6, 7, 8. Let's say having a hard time wrapping my head around this. Let me use this as a support text editor here. If this is our hash, then we can modify the input in a way that the first argument of the sum is going to be all zeros except the leftmost bits. Maybe something like this. So this is 7 bits. Like this. Let's break this up. 8 bits here. Is this 8 bits? No, this should... 1, 2, 3, 4, 5, 6, 7, 8. And these are, this is a packet of 8 as well. So that is the expected output. How do we get this output? For example, if the first input character is no. Something is wrong. This is 9 characters. like this probably. What? 1, 2, 3, 4, 1, 2, 3, 4. Like this. We help text. Okay, I can't write here. I can write to the temp folder help text. Okay. This could be the first number that we input. Oh, there's a 0 missing here. But where is it missing? It's missing here. Yeah. The second input should then resemble this word. One zero zero one. Then this one should be 1101101, and this one should be 0010001, maybe like this. And what am I doing? This is the hash. Oh, no. This right here is the hash file. And this is the input characters. Because when these lines are summed up, they will result in this hash. Let's have a look at what these individual characters are. But maybe this is still too much, because these input characters are going to be... No, they are 20 bytes. 20 bytes, okay. And none of them is going to be a null character, because this entire thing is going to count as a character, as far as I understand. I'm not sure about this one, because this string will be converted. This byte will be converted to a character, and these are not going to be prepended, probably. Maybe we have to somehow intelligently craft the character. I'm not sure about these null bytes. first idea for input characters. Let's have a look at a second round of input characters. 0b, let's create a packet or a byte chunk of 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, like this, and we have to create 4, maybe 5 characters we input that will result in this hash. So for the first character, we're going to just set the first one. Let's see if that is a valid character online. Or in Python, we have the function, the character function, and it will take as input integer of 0b this. Okay, I think the spaces are not allowed. Can't convert non-string with explicit base. Okay, because this is not a string, we don't have to provide a base because we already say it's a binary representation here. Character argument is not in range 256. So this will only consider 256 characters. Let's say binary to character converter. And I would like to provide this character, if this can even be considered a character, because it's way too large normally for a regular character. But let's see. Okay, this is some some binary stuff. Can we provide that? No. Probably setting this 1 to 1 is not ideal. We have to be in the range of 256, so this means we have to stay in this area here. (256) is, I think, 16 bits. Passcode length should be 20 bytes. We provide 20 bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, no. 1, 2, 3, 5. I counted wrongly. And this is one character, this is the second, this. Aha, maybe this means we can use this as one character, then this one, 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 then this one. This means we can use this as one character. Let me just see. What is this as text? Nothing. Binary is really not fun. I need some simpler representation. Why is it printing these odd characters here? I don't get it. No, one character. No, one character is... This should be one character. Why? It's this I, this odd I. What about all zeros? We have to craft a better input. That's very interesting because I have the feeling that we understand the problem, but the challenge is now to craft an input that will kind of allow us to intrude in the system, into the system. So I would like to check out what valid characters would allow us to enter here. This is an exclamation mark. Exclamation mark should be fine. Let's maybe this is character 1. This is character... No, this is character 1. Character 1, character 2, character 3, character 4. The confusing thing is that character 1 and character 2, they are taken as one integer. And then they are added together with all the other integers. But what is an integer in this case anyways? Character 1. Character 2. Integer 1. And this could make up this thing. What if this is character 1 and this is character 2? We can probably all agree on this. This is character 1. Let's just see what happens if we use this as character 1. Exclamation mark. I need something to note that down. No, not like that. Vim. Character inputs. Character 1 is exclamation mark. Then this can be character 2. This is this weird I character 2 is this I. Okay, so this way, by providing these two characters as our first input, integer, this is character 1, this is character 2. This way, we should have covered this part of the hash, these 2 bits. But it is still confusing what to provide here. We can't just put zeros. Or can we? We can provide zeros, I think. Then let's change this word, or let's add the information that this is character 1. This is character 2. Then character 3. This is character 1. This is character 2. Then this is character 3. This is character 4. No, instead of using this here, we have to offset this with zeros. This was a mistake. So this is character 2, this is fine. But the exclamation mark is probably wrong. No. No. That's the I. We can paste that in. That is a valid input. This one. What is this? Nothing. 1, 2, 3, 4, 5, 6, 7, 8. This is binary. These two added together must result in this is horrible. This is really horrible. That's the main problem. The character arguments are not in range. What if I add the largest characters, the largest integers up? What if I add up the largest integers? The largest integers are int 0b 2 3 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 65,535 and 65,535. So that is one integer, and we have that 5 times is this number. So we can't really add this up 5 times and get this result. No, but we don't do it 5 times, but 20 times. That is 131,000. Then let's check what the integer value is of this divided by 5. It's way bigger. The passcode length should be 20 bytes. From 20 bytes, we derive a 4 bytes hash code by chunking the passcode into 5 units of 4 bytes each. As is described here. And the 4 bytes each are added onto each other. How about if this works? New idea. Passcode is 20 bytes. Hash is 4 bytes. If passcode no. Hash is 4 bytes. So this means the passcode can provide 5 chunks of 4 bytes data. Five chunks are added, are summed, checked if resulting hash matches. So we can do the expected hash is 21DD09EC. So how about we provide, come on. Is the server crashing due to me now? Hey, it's not doing anything, oh god. Whew. Why does it not work? Does my keyboard still work? Yes. Can I open a new terminal and just enter that tmux session? SSH. I'm about to forget my idea, so this is not good. Guest. Tmux attach session. Aha. What the hell? This is not my session. Let's exit. Exit. Someone was trying to implement something here. Key. Tmux list session. Yeah, the other one is mine. Tmux attach session T1. Ah, it's 2. That is mine. This one came crashing down. So I will close this terminal now. And that's so great about tmux that all my stuff is still stored and I can now work with it. And we're back. Great. So this was a really nice recovery, a really nice crash recovery using tmux. That's one of the reasons why I use it. Okay. What I wanted to say is, how about we craft input characters as follows. The first input character should be 21000000. Then the next one should be 00dd0000. Then the next one should be 0. Should be this. And the next one should be this. So by summing those up, we would get the expected hash. But probably this first character is already too big. From hexadecimal to text. Let's try to convert this input. 0x 21000000. Convert. Yeah, that does not work. If I convert these characters, I can't even paste them anywhere. Ideally Unicode. Unicode should be the right character format. Okay, but that is not a character. This is a character. This is a character. So let's remove 4 zeros, convert that. Still looks odd to me. This is a character. This right here is 1 byte, one of 20 bytes. Let's try to convert this. Exclamation mark. And the exclamation mark is hunting me today. But somehow it's prepended by this binary character. Why? I have no idea. 0x21 should be in binary a relatively small number. Yeah, 33. So this is definitely part of Unicode in my opinion. Or not in my opinion, this is not an opinionated topic. It took the 0x as input as well. Great. So this is the exclamation mark. Let's translate this into characters. This is the exclamation mark. Then the 2 zeros, how would these be translated into Unicode? Doesn't work. I would like to have a look at the Unicode character set. Zero is the null character. How do we... Wait. Input null character as argument. You cannot. The C program receives arguments as 0 terminated strings. So inputting the null character does not make any sense. So if I'm not mistaken, the exclamation mark followed by 19 null characters. No, not 19. Maybe these kinds of null characters should be working. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 16, 17, 18, 19. Did I miss something? One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 4, 5, 6, 7, 8, 9, 10. 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. There needs to be one more 0. No, still one more. Oh. I think probably the input is already broken up after this right here, because string length, the string length function that is used in the code here, will count the length of the string until it encounters the first null character. So how do we paste in nulls? That is the question. We could do... hex to Unicode string. This looks like a good website. The passcode length should be 20 bytes. How does the character 2100 translate in UTF-16? It's this. Can bash handle UTF-16? By this logic, if this is 16, then we should be able to paste 10 of these characters into the binary and produce the output that the passcode length is basically accepted. 1, 2, 3, 4, 5, 6, 7, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is this not accepted? 7, 8, 9, 10. I think the string length in C is making our lives hard. Yeah, the length of a C string is determined by the terminating null character. A C string is as long as the number of characters between the beginning of the string and the terminating null character. I've had a look at a couple of blog posts about this crack me, and I found that the initial things that we were doing were actually correct. So what we initially did was we took this hash code, we divided it by 5 because it is summed 5 times. Of this I would like to get a hexadecimal representation. So we're going to take the hash code, divide it by 5, and then print it as a hexadecimal number. Can we actually calculate using hex numbers directly in Python? Yes, we can. Then we divide this by 5, and how can we print the result as hex? It is annoying. Anyways, we can divide it by 5 and then multiply this by 5 again, and it will not result in the same string. This is a discovery that we already did, so there will be a reminder. This is the thing that we have to offset from this. So this is the hash, and we have to subtract this. So this will be the remainder. Let me repeat that. Remainder. Like this. Or let's just call it offset. Offset. If I print the offset, it's just 4. So a valid input would be this plus this plus this plus this plus 4. Can we somehow forge this into a string? My first idea would be to do this manually. We could do probably this. Maybe this is already workable input for the call command. If we supply this 10 times, then that should be 20 bytes, because 1 is 2 bytes. 3, 4, 5, 6, 7, 8, 9, 10. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Doesn't work. Why? Probably because of the 0 characters. Can Python print this maybe? Print 0x21. What will it print? Okay, it will just do this. Python print hex to character. Maybe to Unicode. Print Unicode and then you need to tell Python it's a Unicode literal. The leading U does that. It will even work for multiple characters. So let's test that. Print U 0x21. No, that did not work. I have to specify the U outside of these single quotes. Like this, still doesn't work. How do we print this to Unicode? U\xd3. The 0 might be confusing. Aha, okay. \x to 1. What does happen if we append another x to 1? Does not understand it. We have to do \x to 1. This is already good. This way we can print what we need using Python. And what do we need? We need this. We need to print this. Let's have a look at this main method here. The main method reads every. So I'm just thinking about the order of how to pass this into the method. The main method takes in a character array, which is the string, which would be whatever character sequence represented by this. And then it takes in, then it accepts a character, no, 2 characters, no, 4 characters. It takes 4 characters, 4 Unicode characters, and converts them to 1 integer. This means that the first character represents the largest bits of the integer that is summed. This means that from here, the first character, no, the first character I don't know. Let's just well, what would be the next step? We somehow have to provide the hexadecimal numbers to the script, and we could do that using call, and then we these are the characters that we figured out earlier. Yeah, that's the tab character, and yeah, these are the characters that we figured out earlier. So these would have to be supplied 4 times, and at the end we would need the offset which is just 4. And this could be supplied. How? I'm thinking of the null, of these null bytes. These would terminate the argument input. But anyways, 0x. Now how do we represent 4? Like this, \x 4. Doesn't work. Print this 4 times plus then print the 4, which is part of this 4 bytes large integer. That is the integer. Ooh. Print this times 4. Invalid \x escape. Where is it invalid? I'm saying print to Unicode \x0 \x4. These are all valid. These work. Plus U. I can't probably append like that. Python concat how's this called? Here we print. we have to print this thing 4 times, followed by can't decode. I mean followed by the 0, but here it says can't decode bytes in position 64 to 66, truncated x zeros. This needs to be longer. This needs to be x00. Okay. So here we can provide x00 and then the 4, which is the remainder. All of these are characters that don't exist or are not even printed to the console. But I think the Python print command prints them to standard out anyways. Let's have a look. Print standard out. What's the difference between sys, standard out, write, and print? Print is a wrapper that formats the inputs. By default, this object is it calls the write function of a given object. By default, this object is sys standard out. So it will write these into standard out. And I suppose that we can just... Can we? I'm not sure. No, we can't. We probably can't put them in the shell directly. We want Python to convert them to Unicode characters. And is it possible to invoke this string as an argument with this binary? Invoke command run Python one-liner in bash script. No, I don't want to exit this. Let's exit this and do Python help. Python help does not exist. Help, like this. Help. Welcome to Python 2.7. This is the online help utility. Okay, I don't need this. Exit. Python execute command in terminal. No. I want to execute Python command in shell. Bash how to pass the output of one command as the command line argument to another. That is what I need. You can use backticks to evaluate a command and substitute the command's output like this. Okay, let's see. Let's go over here and but how do we get the command output? And let's just copy this and try it. Number of files in this directory, 3. So it prints, the echo prints number of files in this directory, and ls piped into word count lines. Number of files in this directory is 3. Like this, we could execute somehow the Python command. And the Python command, since we can't really create files on this machine, I would like to run this inline. Run Python command inline. How to execute Python inline from a bash shell. Python-c. C command. Specify the command to execute. This terminates the option list. Following options are passed as arguments to the command. So I think Python-c, and then we print this and this. Does not work because we have to probably put this in quotes. Okay, this executes this command inline. This is getting complicated. And this is the forged hack, the forged exploit. And now I could call the collision command and then use backtick and then call this Python-c command here. So let's do that. /call backtick. Go to the end of the command, another backtick. And that doesn't work. ASCII codec can't encode character. Ordinal not in range. But this works. And just adding the backticks seems to not work. Why? Do we have to echo this? No. Python-c print u, so it prints the entire thing, and this works. However, the same command does not work if I enclose this command in backticks. Why? This function here encloses the command in single ticks. Maybe that is something worth trying. No. For that we need to single quotes, I mean. That works. Now backtick at the end and backtick at the beginning of this. Echo. ASCII codec can't encode character. XDD in position 1. So this one cannot be encoded. Why? Ordinal is not in range. So this is trying to print the output. I think if we just call the Python script, it will somehow format the output to be displayable. And if we do echo and then echo just the Python's output, then somehow the formatting does not work. But no, this looks like more like a... What kind of error is this? Is this a Python error? Can't encode character in position 1. Looks to me like a character. Use bash redirection. Do not use string to convert from Unicode to encoded text. Instead use encode to encode the string. Or work entirely in Unicode. Unicode how to. Unicode is a sequence of code points which are numbers from 0 to this number. The sequence needs to be represented as a set of bytes. Yeah, that's clear. The rules for translating a Unicode string into a sequence of bytes are code and encoding. We have a Unicode string that is this string that we're trying to print, and we want to get a sequence of bytes from it. The first encoding you might think of is an array of 32-bit integers. Why? In this representation, the string Python would look like this. This would be the P. Yeah, and that does not work because there are several 0 characters here, which we already found are causing lots of trouble. And here it says it's not portable. Okay, different processors order the bytes differently, but it's very wasteful of space. In most text, the majority of the code points are less than 127 or less than 255. So a lot of space is occupied by 0 bytes. Yeah, and that is not what we want. It is not compatible with existing C functions such as string length, which is also what we're facing right now. So a new family of wide string functions would need to be used. Many internet standards are defined in terms of textual data and can't handle the content with embedded 0 bytes. Yeah. Praise the Lord, this is exactly what we need. So what is the solution? Generally, people don't use this encoding. Instead choosing other encodings that are more efficient and convenient. UTF-8 is probably the most commonly supported encoding. It will be discussed below. Encodings don't have to handle every possible Unicode character, and most encodings don't. Encodings don't have to handle every possible Unicode character, and most encodings don't. For example, Python's default encoding is the ASCII encoding, which is what we're facing here. The rules for converting a Unicode string into the ASCII encoding are simple. For each code point, if the code point is under 128, each byte is the same value as the code point. If the code point is 128 or greater, the Unicode string can't be represented in this encoding. Python raises a Unicode encode error exception in this case. What's the solution? I need a solution. I'm so stupid. I used the completely wrong. I used the number that was used to calculate the offset to generate the print statement, but that is obviously wrong. I need to use, this is the target hash. This is the offset generator thing. If we use the target hash and divide it by 5, or should we do 4? Let's check the hex number of this. Okay, then we do print u this. Let's craft it manually. \x, no, \x 06. No, 6c \x 5c \xec, no, ce \x c8. Okay. Now the correct thing to input here So this is one of the inputs that we want, probably. The next of the inputs that we want is print. Is this plus 4, the reminder? So this plus 4. This is the last one. Last is equal to hex of that number. Last. Now we can take this print statement. This should be repeated 4 times. And then we will append this as well. Like maybe the formatter. Wait. Python print formatter u. I'm not sure how it works. Python print Unicode. And we're now going to print this. Six C 5C EC 6C 5C EC 8. 1, 2, 3. Probably have to do 0, 6. 5 C 0, 6 C5, not 5C, C5 CE and C8. This looks weird, but if we can get this to evaluate in here, this would be already a good progress, because this should now be 20 bytes. So we do a Python C to evaluate within the command line. And I would like to evaluate this right here. Normally I would copy this using tmux, but it's quite, well, this is an unconfigured tmux and this is a bit annoying here, so I do it manually. Oh, Something happened. Print C. It prints the usage, so there's no error right now. Does the print C even work? Let's check that. I don't know. Maybe echo. I don't know. What if we just do this? No, this doesn't work. I know why. It doesn't work because I have to quote the print statement. And there's the error again. Great. You might need to set Python IO encoding before running your Python script in the shell. For example, I got the same error while redirecting the Python script output into a log file. After changing Python IO encoding to UTF-8 in the shell, script executed with no ASCII error. But that does not really explain why this works without the echo statement, or does it? Oh, okay. Okay, why? Okay, I guess that means we can now try to evaluate the print statement using the challenge binary. Passcode length should be 20 bytes. What's wrong? This is not printed 4 times. It looks like... Oh no, it is. That's once, twice, 3 times, 4 times. That's once. 2, 3, 4. 5. XC, why XC C8 it must be. No. CE slash backslash C8. So that is the print statement that I think should work. And of course we have to do the Python evaluation like this. End of line while scanning literal. There's a single quote missing. Passcode length should be 20 bytes still. Why? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 input bytes here. Well, it would be awesome to if the executable told us how many bytes it is receiving. This is 20 bytes. I'm not sure about that environment variable that I said. Python IO encoding, UTF-8. UTF-8, is UTF-8 the same as Unicode? Is UTF-8 Unicode? Broadcast message, 24-hour interval system initialization will be started after 60 seconds. Okay. Try to erase me. Connection to pwnable is closed. I will reconnect. I will do tmux attach session T1. No sessions, T2. No sessions. They destroyed my stuff. I will get this done today. Tmux list sessions. So that is Tmux. Here's the script. The executable. So let's start again. Vim call C. I need this hash code right here. Here, let's create an instance of Python. We will say hash is this. Then we will say input is hex of hash divided by 4 or 5? 5. Like this. And the reminder was 4, and we know therefore that the input Python C, we're becoming pros at this right now. Python C, we print U, and then we have to print this, the print input. We have to print this. Here it takes, oh, I can even scroll here using Tmux. It's interesting. Here it says the passcode should be 20 bytes. Okay, that's clear. Then it takes in the character pointer. The pointer of a character. What? The index 0 of an integer pointer, no, the 0th byte of an integer is it big endian or small endian? C integer ND Suppose I declare an integer on a little endian machine. Should not matter to you how the data is represented as long as you don't transfer it between platforms. It's hidden from you. Shouldn't bother yourself with it. Okay. But since I pass characters or strings of characters into it. For example, this input, it matters whether this is the big part of the integer. No, or does it matter? No. Okay, let me try something. Here we want to evaluate a Python script, Python C, and we would like to do the following: Python C, and here's the command print u \x6. No, \06. \x06 \xc5 \xce \xc8. Unexpected end of file while looking for matching. Yeah, sure. Backtick. Oh no. Like this. No, this, and backtick. ASCII can't encode. Why can it not encode the characters in position 1, 2, 3? 1, 2, 3. This is position 1. This is position 2 and 3. But I bet it can encode them if I just do this. Yeah, sure, then it works. Why? Hex to UTF-8. Convert hex to character. C5 converted. That's a converted character. Using UTF-8, it's going to output something odd. Why does it output something odd? Because we already converted to Unicode here. So I think this should be fine, actually. CE. Is this? C8 is this. 06 is this. Yeah, some magic binary character. ASCII codec can't encode characters in position 1, 2, 3. Yeah, but where does it try to encode the characters to ASCII? Is this a conflict here because of this U? We print to Unicode. We print out Unicode and then the console does not understand it. Did that work? What if we do just echo? Well, here at this point we don't care about the encoding, it seems. We just print these bytes. So I'd like to print this times 4. Does that work? Can I print this 5 times? Okay, this will at least say, accept that we input 20 bytes. It's so weird. And then I would like to print this 4 times plus this input hex of input plus reminder. Does that work? No. Hex of hash divided by 5 plus 4. This one. That is the string we need. 0x6c. No. 9. x06 x C5 XCE XCC wrong passcode. I'm fairly sure the passcode is correct. It has just something to do with my understanding of the C code. Because we're taking a pointer to the first location of a character, first character. This is going to be converted to an integer pointer, and the integer pointer points to the first What does the integer pointer do exactly? Where does it point to? I know what. Let me just draw this for you. So we have imagine this is a container of our characters, for example, C, A, B, D. And each of them sits in their own slot. We input to the method a character pointer that points here to the first entry. Of course, this is a bit longer, but it points to the first entry, and by using the indexes, we can refer to the other entries of this pointer. So this is the pointer P. Once this pointer or character array is converted to an integer array, the integer array will let's say int will still contain the exact same information C, A, B, D, but it will point here. Why will it point here? Because there are more such elements here, and it always points to the leftmost, to the rightmost place in memory. Or is that the case? Hard to say. we convert it to an integer pointer. Integer, well, or no, it will probably still point here, but now this entire thing, can I pick another color here? This entire thing here, this is now the integer. Before that, this was the character, this was one position. Now this entire thing is one position. So what's different now? This means that the last character is now the smallest part of the integer. The last character that we input for each 4 bytes is this small part. So this is the yeah. Does this make sense? So everything that was before the conversion was a character. Before the conversion, by accessing the first index, we would that is it. Before the conversion, by accessing the first index, let's say P0 or P at index 0, we would get this byte right here. But after the conversion, say after, this is green now, the conversion is green, the first index, if we would index it, well, now the first index will point to that entire thing, and now the small bytes, the least significant bytes are this. So we put in a character array. It is converted to an integer array or pointer. And then we sum up the integers. We just crafted our constituents of the hash code, the individual summons. But how? So this is now the least significant part of the information. Well, but still this should be handled segment by segment. The hash code here, how is it how is it called? Denoted. C language hash. No, not hash. Hexadecimal endianness. When you do assign to a variable, you're setting the value, not the representation. The hexadecimal number is the same as the hexadecimal number this, so that what gets assigned. The fact that the number is represented in hex does not change how the assignment works. If you did something like this, then X would contain the value 4 on a little endian machine. Okay, we're doing something like this. The literal 0x04 followed by many zeros means the number 6, 7, blah 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 will be stored means this number. It will be stored differently in memory depending on whether little endian or big endian byte order is used. How do I know? Well, we're printing. What are we printing here? We're printing this x06 first. Is that correct? We are printing x06 first. So if we're assigning 4 bytes of free space here, and then we write, and then we copy this character array into this, the x06, is it written at the beginning or at the end of the memory word? Okay, there's a Python script that says that prints the byte order of the system. Here it says little endian. Difference little and big endian machine. Big endian is an order in which the big end, the most significant value in the sequence, is first at the lowest storage address. At the lowest storage address. Yes, in little endian, it is an order in which the little end, the least significant value in the sequence, is first. This is a little endian machine. So you have to write into memory the small bytes first, the little endian bytes. So let's try to recraft this statement right here. Let's begin with the last byte. \xc8, then xce, \xc5, \x06. So this is now one integer. This is a complete entry of a memory word. So if we insert multiple such words, the endianness does not matter anymore. Times 4, and now let's reverse this. This right here, xcc \xce \xc5 \x06. And that's it. That's it. Oh my god. Oh. Yes, we managed to create a hash collision, and it was so much work. It was so cumbersome. It was incredible. Is this really a beginner thing? I mean, there was so many details, so many low-level details of language and machines. This took me so much time. It's incredible. Anyways, we managed to get it working. Of course, I checked some information, some blog. during my lunch break, but still it was such a trouble to understand this solution. Incredible. We definitely learned a lot during this about character sets, character encoding, about executing Python inline, passing on command outputs as command arguments in Bash. So many things we touched. We even recovered from a machine crash using tmux, and then the machine got wiped out by the hacking website, and we had to start from scratch. But overall, this was a great odyssey, and we learned so much, and I hope it was enjoyable for you. And yeah, that's what happens when you try to hack something or exploit something and you have no idea yourself, or you have not prepared it. This was a real life demo of me trying to solve this riddle, and this is how much time it takes. This is just natural software engineering, natural hacking. If you want to learn something, you have to go deep into a problem and figure it out, and this is the only way to really expand your knowledge. Anyways, if you enjoyed this, then please leave a like and subscribe, and see you next time. Bye bye.